This is Professor Broker, and this is Thinking Like an Economist, Part 2. So, in Part 1, we looked at how economists think and different, micro and macroeconomics, positive and normative statements, and we looked at our first economic model, which was the circular flow diagram. Now we're going to look at our second model, which is the production possibilities frontier. We're going to spend a little bit more time with this one. So the production possibilities frontier shows all combinations of two goods that an economy can possibly produce given its resources and technology. It lets us know the productive possibilities, given the name, of a given economy. And we're going to be able to illustrate concepts such as trade-offs, opportunity cost, efficiency, inefficiency, unemployment, and economic growth just with this model. And it'll help us give us a representation between resources and production as well as consumption. And we will use this model later in Chapter 3 to help us understand trade. And so it'll be important for you to understand this model and learn it now before we get to later chapters when we use it again. Okay, so let's go ahead and construct our first example of a production possibilities frontier by assuming a couple things about an economy. So first, we're going to simplify an economy to only producing two goods. Now, obviously, that's a simplification like we talked about. Our economic models are simplifications of reality. Clearly, just about any economy can make more than two goods. But we're only going to focus on two goods to simplify the math and simplify the graph. And the principles we learn from this, I think, will apply to a much larger economy, say like the United States. Okay, so we have an economy, and they can make either computers, okay, or let's look over here. They can make computers or wheat. Okay, but to make either one of these, it takes labor resources. It takes resources, and specifically, we're only going to look at labor resources. So that's another simplification. Is we're assuming that the other resources we're just not including right now, land and natural resources as well as capital resources. We're just focusing on labor resources. Okay, just to keep it simple. Okay, and this economy has 50,000 total labor hours. Okay, total labor resources that they can use, 50,000 labor hours. And it costs 100 of those labor hours to make one computer and 10 of those labor hours to make a ton of wheat. Okay, so we can make two goods, and we have a set of resources that we can use to make those two goods. And we're going to be able to make various combinations. So for example, if we devote all of our labor resources, 50,000 hours, to making computers, then obviously we would have none left to make wheat, okay? And how could we translate this into production? How many computers would 50,000 labor hours produce? Well, it would clearly make 500. 50,000 divided by 100 would give us 500 computers, okay? And of course, if we didn't devote any resources to making wheat, then clearly we would not have any wheat. Okay, so that is one possibility. This would be devoting all of our resources to computer production and none to wheat. We could make 500 computers. These are some other combinations, right? We might call them point B, C, D, and E. And if we devote 40,000 labor hours to computers and 10,000 to wheat, we would get 400 computers produced and 1,000 tons of wheat. And then so on and so forth. Point C, 25,000 labor hours would be converted to 250 units of computer production, and 25,000 hours of labor devoted to wheat production would translate to 2,500 units of wheat production, and so on and so forth. Okay, so basically this slide is meant to show you that our production levels, which we're going to use to construct our production possibilities curve, are really derived from our resource availability and how we divide up those resources. Okay, so that's what we're working with. Okay, now let's take those numbers that we just calculated for points A, B, C, D, and E. Okay, our computer production and our wheat production. Let's consider them as X and Y coordinates. Okay, so let's go to a graph and let's plot our points. Right, so this would be an X coordinate. This would be a Y coordinate. Okay, let's plot those points on this graph with computers on the X-axis and wheat on the Y-axis, and see what we get. Okay, so I'm going to plot point A at 500 computers and 0 wheat. Okay, I'm going to plot point B at 400 computers and 1,000 units of wheat, and so on and so forth. Okay. Now you can see that this appears to make a straight line, right? I'm going to connect the dots, and it looks like a linear line, which means it'll have a constant slope, which we'll get back to in just a second. Now, Now remember, what does this line mean? Okay, remember how we constructed it. We constructed it and we said that these points represent us using all of our resources, okay, available resources, 50,000 labor hours in production. Which means if we use all of our resources, we will be somewhere on this line. Okay? Now, no point is better than any other point on this line. They're all, what we'll look at later, called efficient. These points are all utilizing all of our available resources, and there's really no way to tell which point on this graph is better than another one on the line given the available information. But what it does tell us, right, is that we don't have enough resources, okay? That this line tells us that we do not have enough resources to produce anything outside of the line. I mean, if I want to produce 6,000 tons of wheat and 600 computers way out here, right, we automatically know, because it's outside the line, that we don't have enough resources, okay? Because we constructed the line using all of our resources, okay? So we don't have any left. Okay, and we'll talk about some other points here in just the next slide, okay? So now, points on the line obviously are possible, and they're going to be what we call efficient. Now let's look at another point, a point F. This point is going to be us producing 100 computers and 3,000 tons of wheat. Okay, and let's discuss it. Okay, so again, 100 computers, 3,000 tons of wheat. Where would that be? That would be right here, point F. Okay, now remember, we constructed the line using all of our resources. Those were efficient points. Okay, this point is inside the curve. Okay, now, can we produce inside the curve? The answer would be yes, because this line represents utilizing 50,000 labor hours. Point F, right, would only require 40,000 labor hours. Anything inside the line, it means we are not utilizing all of our resources. So clearly, we could decide as an economy to produce at point F. But that would clearly not be efficient, because we could actually get more of either good without sacrificing any of the other good by simply moving towards the line. Okay, and so points inside the curve are possible, but they're not efficient uses of our resources. Okay, that's what point F would be. Now, let's look at another point, point G. This would be producing 300 computers and 3,500 tons of wheat. Okay, so 300 computers and 3,500 tons of wheat. Looks like it should be about right there. Close enough, right? And that is point G. Now, what should we automatically know about point G? Point G, because it's outside of our curve, okay, that means that because this line means anything on this line would require using 50,000 labor hours, which remember is how many labor hours we have available. Anything outside the line would require more than 50,000 labor hours. In this case, it would require 65,000 labor hours, which we don't have, which means point G is not possible. Or you might also see the terminology not feasible or unattainable. Any of those words, not possible, unattainable, infeasible, anything that means we can't do it, that could describe point G. We can't do it in this economy. We might want to. It would be nice to have more food and more computers, but we just don't have the resources to be able to do it right now. It's wishful thinking. Okay? So this is what we know so far. We know points on the production all points on the production possibilities curve are efficient. It means they're possible and we're utilizing all of our resources efficiently. Points under the curve are inefficient because we're not utilizing all of our resources. It is technically possible to produce under the curve, but we have unemployed workers, or we have factories that are idle, which is not good for the economy. So we would like to move towards the curve. We would like to be producing efficiently somewhere along the production possibilities curve. Okay? And then points above the production possibilities curve or frontier are unattainable or infeasible or not possible, because they're not possible given the current level of resources and technology that we have. Okay? So that's key to know. You need to know the difference between being on the curve, in the curve, and outside of the curve. Okay, next, the production possibilities curve and opportunity costs. Now, you'll remember from, middle school that the slope of a line equals the rise over the run, okay, as we move from one point to another. So let's just look at our at our production possibilities curve right now. Now, because this is a linear line, it will have a constant slope. Well, what is that slope? Okay, you can probably identify it just by looking at it, but let's just break it down, right? If I start here at this point, right, and, I want to produce 100 computers, bam, right? Okay, that's going to be my run, so that's going to go in my denominator. But how much do I fall to get back on the line? Okay, well, I'm going to have to go down by 1,000, right? So in other words, moving in reverse, in order to go from this point to this point, I would have to go up 1,000, right, and decrease by 100, or vice versa. I would have to go over by 100 and decrease by 1,000. However you do it, you're going to get negative 1,000 over 100. Simplify that, your slope is negative 10. The slope of this line, you could also take 5,000 divided by 500, right, and realize this is a negative slope, and you'll get negative 10. However you want to do it, the slope of this line is negative 10. Now, what does that tell us? Okay, the slope, okay, of the line tells us what our opportunity cost is. For example, what it tells us here is that for every computer that we want to produce, this is assuming that we're on the production possibilities curve. So utilizing all of our resources, what this means is if we want to produce an extra computer, we're going to have to sacrifice 10 tons of wheat. Okay, that's what that slope tells us. So the slope tells us the opportunity cost, which illustrates the fact that societies face trade-offs. So again, we're producing, wheat and computers, and if we want more of one of them, there's going to be an opportunity cost. We're going to have to sacrifice production of the other good to get more of the one good. So for example, we might be in society, we might be talking about, healthcare or education or construction. And, as a society, we might be saying we want to spend more on one of these areas. Well, and that's all well and good, and that's fine. But what the production possibilities curve is telling us is if we are on our curve, okay, then getting more of one of these areas, so spending more money, say, in construction, might mean we have to sacrifice spending in either education or healthcare or some other field, okay, or vice versa. There's an opportunity cost associated with resource diversion, okay, which is, again, we talked about governments, people, households, businesses, they all face trade-offs. That was one of the principles of economics. And we're seeing that here in the production possibilities frontier. Okay, now, the shape of the curve. We were looking at a straight line. A production possibilities curve does not have to be straight. It can be straight or bowed outward. It could technically be bowed inwards, but that's not really, we won't look at one of those because that's not really realistic. Okay, so really, in our case, one can either be straight, which would mean that the opportunity costs in that economy are constant, okay, or it could be bowed outwards, which means that the opportunity costs are changing, specifically that they are rising, okay? And that's what I want to look at next, okay, is a slightly different production possibilities frontier. Okay, so in this economy, we're switching gears here. This economy is making pizzas and mountain bikes, okay, and they can make some combination. And notice, though, that this curve is not linear, which means the slope is not going to be constant. The slope is going to change. The opportunity costs are going to change in this economy. Let's look at how. Okay, let's look at 3 points, points A, B, C, and D. And starting at point A, see if you can tell me what it would cost, in the terms of opportunity cost, what it would cost this economy to produce 200 more mountain bikes. Okay? Well, to answer that, so we're starting at point A, we want to produce 200 more mountain bikes. That will have some level of cost. There will be a cost, an opportunity cost associated with that. Okay? We will have to sacrifice some pizza production. Well, right now at point A, we're making 200 bikes. To make 200 more, we would need to make 400, and that would take us to point B. Okay? So to go from point A to point B, what would we have to sacrifice? Well, it looks like roughly we'd have to sacrifice, we'd give up about 75 pizzas. We'd go from about 475 down to 400 pizzas, which means a reduction of 75 pizzas. Okay, so that would be the opportunity cost of producing 200 more mountain bikes. That doesn't seem too bad, right? You get 200 bikes for giving up 75 pizzas. Seems like it might be a reasonable trade. Well, let me ask this question. Let's start at point B now and ask the question, what does it cost to produce 200 more mountain bikes? So now we're at point B, producing 400. Now we want 200 more mountain bikes, which would take us to 600, which means we would be at point D. Well, to go from point B to point D means we would have to sacrifice 400 pizzas, right? To gain those last 200 mountain bikes, we would have to give up 400 pizzas. Now, again, maybe that's a good trade, maybe it's not. But notice the big key here is that each time we were increasing the number of mountain bikes by the same amount. But notice that the cost in terms of pizzas that we had to give up increased dramatically. Okay? And that's because of the shape of the production possibilities curve. Or really, I should say, that this phenomenon of what we call increasing opportunity cost is what gives the production possibilities curve its bowed out shape. Okay? Now, let's discuss a little bit about why a production possibilities curve might look like this. Why might opportunity cost increase as we increase production? Okay? Again, as it's bowed outwards, the production possibilities curve becomes steeper. Opportunity costs begin to increase. Okay? So as we move from point A, for example, to point B again, we may not have to initially give up very many pizzas to gain mountain bikes. That's because, think about it this way, the reason for this is because imagine our workforce is divided between half of our workforce roughly, which is really, really good at making pizzas. They have the skills and the personality and the desires and the work ethic to be really good at making pizzas. Okay? But it also means that they're not that great at making mountain bikes. And let's think about the other half of the population of our workforce, which is actually really good at making mountain bikes. They have the technical know-how, and they're good at working with their hands, and they're good at engineering and so on and so forth. And they just have the human capital and the skills and the traits that make making mountain bikes easy for them. Okay, but it also means that maybe they're not so great at making pizzas. Well, if we go from say point A and we shift to making more mountain bikes, who are we probably going to ask first to stop making pizzas? The people that are good at making pizzas? No, of course not. We're going to ask the people that aren't very good at making pizzas to stop making pizzas and to go ahead and start making mountain bikes. That makes the sacrifice or the opportunity cost very small initially. But as we move down the curve and it becomes steeper, okay, then if we want more mountain bikes, okay, then we're going to have to sacrifice comparatively more pizzas as we move down the curve, just like we saw before. Now, the reason is because once we get to point B, notice that we've probably already shifted everybody that's good at making mountain bikes over here. So now, if we want more mountain bikes, we're going to have to start asking people that are actually good at making pizzas. We're going to have to say, hey, you're actually the best at making pizzas, but now we need you to stop that and start making mountain bikes, okay? And remember, they're not that good at making mountain bikes. So we're going to gain relatively few mountain bikes for a big sacrifice of pizzas, okay? So the fundamental reason why this is happening, again, we call it the law of increasing opportunity cost, but the reason it's happening is because different workers have different skills and thus different opportunity cost of producing one good over another good. In other words, we have differentiated resources. Some resources are better suited for certain productions than others. You can also think about this in the context of land use, right? So if there's a farmer that has some land the farmer has is not very good at growing crops. Other land is really good at growing crops for whatever reason, the soil composition or whatever, okay? Well, if this farmer wants to start, producing energy using solar panels, and he needs to install the solar panels over some of his land, which land is he probably going to install them on first? The really good land or the really poor, land for farming? Probably this land, right? Because and if once he does, the sacrifice, the opportunity cost in terms of the number of crops he'll lose will be very, very little because this land didn't grow very many crops anyway. But if he wants to install more solar panels, right, where's he going to have to install them then? On his good land. And the opportunity cost of that would be very high. And so thus, this farmer in this situation would also have increasing opportunity cost. Why? Because of differentiated resources. Okay? So make sure you understand the law of increasing opportunity cost. That'll be important as we move forward. Now, moving on to our last item, economic growth. Okay? Now, can we ever produce more than 500 computers Okay? For example, can we produce 600? Or more than 5,000 tons of wheat? For example, can we produce 6,000? Well, the answer is currently no, because that would be unattainable. We don't have enough resources. So if we want to produce, say, another 100 computers starting from 500, or an extra 1,000 units of wheat starting from 5,000, we're going to need more resources, more labor resources, more other resources available, or better technology to be able to achieve those production levels. Then we would actually be able to, if we got more resources and better technology, we would actually have a new production possibilities curve that's shifted outward away from the original one, this new red line. Okay? What this new red line represents is economic growth, or the ability of our economy now to produce more goods and services, in this case, more wheat and more computers, which means our citizens can then consume more goods and services, okay, as a result of economic growth, which would increase their standard of living. So let's talk about that for a second. If you're familiar with the show Downton Abbey on PBS, it is a show about a very wealthy aristocratic family in the early part of the 20th century in England. Okay, we're talking the one percenters here, the 0.1% of the one percenters. They're the wealthy of the wealthy. Okay, now, but can you think of anything that this rich family didn't have access to or couldn't enjoy 100 years ago that you today, as a non-rich person, can probably enjoy or use? Well, I can think of lots of things. For example, they didn't have vacuum cleaners back then, right? They didn't have stovetop ovens. They didn't have dishwashers. Okay, now you might say, yeah, but they had servants for all that and things and so on and so forth. Okay, well, what about big screen television, right? What about a smartphone? What about the access to the internet? What about basic vaccinations and other just basic, penicillin and other basic medical things that make our lives better off? These are all things that even middle class and even many low income Americans have access to that even the super wealthy did not have access to 100 years ago. Okay, yet we enjoy many, if not most, if not all of these things. Okay, and they make our lives better off. So how is it that we can enjoy these wonderful, things like smartphones that have more technology than the Apollo spacecraft that went to the moon, okay, and yet the super rich didn't have access to them? It's because of economic growth. How do we get economic growth? How do we get a higher standard of living in a country? It's simple. A country's standard of living depends on its ability to produce goods and services. It all goes back to production. If a country can't produce goods and services productively or efficiently, then they're not going to have a very high standard of living, and vice versa. If a country is very productive then in producing goods and services, then they will be able to consume at a high level, increasing their standard of living. Okay? And this was actually one of the principles, the macro principles of economics from Chapter 1 that we didn't get to, that I'm talking about now, okay? Because I think it relates to the production possibilities curve. This idea of economic growth. And a country's standard of living depends on its ability to produce goods and services, okay? Now, so then you might ask, the logical question is, well, how do we increase a nation's ability to produce goods and services? Because that seems important. If we can do that, then we can increase standards of living over time, which is important to, most people around the world. Okay, so how can we get higher levels of productivity? We don't have a silver bullet, but there are some things we know. For example, technology. So as technology is dispersed and disseminated throughout an economy, okay, for example, computer technology, that tends to, over time, increase the productive capabilities of that economy. So new technologies are very important. Human capital. Human capital is your mental abilities, your physical abilities, okay, your character, your work ethic, okay, your knowledge, your experience. These things make up your human capital, your abilities as a human, okay, and the more human capital that a nation has, the more productive they tend to be. The key is how do we improve human capital? Where there's a number of different ways. One of the key ways is through education. And so the more educated a society is, specifically with critical, being able to critically think and solve problems, the more educated a society is, then the more human capital they will tend to have, and the more productive that society will be, which will tend to increase their standards of living. Okay? Another one is physical capital. This is like machinery and equipment. You can think that a farmer with a combine will be able to farm a lot more, harvest a lot more crop over a lot more acres than if they were trying to harvest it by hand. Physical capital makes us more productive. So the more physical capital we have in our economy, the more factories and machinery we have, the more productive we are, which means the higher standard of living that we should have. Okay, and then finally, trade, free trade. We'll look at this more in Chapter 3, but the more isolationist that a nation tends to be, the lower standard of living that they tend to have and the slower economic growth. This is seen around the world. Also, countries that tend to be more open to free trade tend to have higher growth rates and higher standards of living, and specifically higher rates of increased standards of living. And so we'll look at that more in Chapter 3. But so again, we want higher standards of living. We need to be more productive. Now, when we become more productive, though, as our economy grows and changes, a process begins to happen called creative destruction. Okay, some people are against economic growth because when our economy grows and expands and changes and improves, sometimes it's not always an even and necessarily a fun or a painless process. So let me just give you one example of that. In 1900, half of all Americans, about 50%, worked in farming or ranching. Okay, they were directly farmers or directly ranchers. Okay, today that number is less than 1 in 100, less than 1%. Okay, and it's still falling. Okay, so you can begin to think, well, gosh, as our economy has changed, there's a lot fewer farmers and a lot fewer ranchers. Okay, and some people are worried about that. Should we be worried? I'm going to say no, and here's why. Number one, we have not starved to death. In fact, we produce more food today with fewer farmers than we did 100 years ago when we had half the population farming. The reason fundamentally is because American farmers are so much more productive that we don't need half the country farming. We can produce far more food with less because of technology and machinery and human capital and so on, those things we talked about. Okay, and so food production has not been an issue, even though fewer people are farming. But then you might ask, okay, but what happened to all those people who used to be farming? New technology has put some of those farm hands out of work and so on and so forth. Well, one key fact is that we don't have a 49% unemployment rate, which means all of those former farmers are not unemployed. Well, what are they doing? Well, they're doing all kinds of things. Those individuals that would have been farming 100 years ago are now fixing our cars, which didn't necessarily exist 100 years ago. They're designing our computer software. They're doing a whole lot of things. They're doing jobs that wouldn't have even existed 100 years ago if it hadn't been for economic growth. Okay, and so economic growth does destroy some jobs and automobiles is a good example. As the automobile was introduced, right, you can think about the number of people that put out of work. That put a lot of blacksmiths out of work, saddle makers, leather workers, carriage makers, horse and buggy makers. It put them out of work, right, because this new car didn't need the horse, and so we didn't need a blacksmith as much, and so on and so forth. But you can also begin to think about the number of jobs that the automobile did create. For example, now we needed factory workers to build the automobiles. Now we needed auto repair technicians, and so on and so forth. And so as the economy grows and expands, some jobs are destroyed, a lot more jobs are created, and over the process of creative destruction, the economy should become more productive, thus increasing our standard of living. Okay? So again, just as a summary, a production possibilities curve shows us combinations. So we looked specifically at an economy making two goods, okay, but the same principles would apply to a bigger economy, a real world economy. And we saw that, there were trade-offs. If we want more of one, production, we're going to probably have to sacrifice some of another production. That's an opportunity cost. That's a trade-off. We looked at the concepts of efficiency and inefficiency, unemployment with inefficiency and not utilizing all of our resources, and also economic growth and expanding our standard of living and our productive capabilities. We looked at the law of increasing opportunity costs, which means that we have a bowed-out shape for our production possibilities frontier. And if we have a straight or a linear production possibilities frontier, that means we have constant opportunity costs.